So we have here a diagram of exactly how much light of each type gets through, or how much electromagnetic waves of each frequency gets through. So we can see that the gamma rays and X-rays are almost entirely absorbed by the upper atmosphere, and most of the ultraviolet is absorbed by either the upper atmosphere or the ozone in the stratosphere. Then we have a small window where we have visible light that doesn't get absorbed at all. After that, we've got infrared and microwave light getting absorbed by water vapor and carbon dioxide in the air, followed by another gap of radio waves. Once the radio waves get to a long enough wavelength, however, they start being reflected from the atmosphere. So it turns out that, as I mentioned before, because the upper atmosphere absorbs gamma rays and X-rays, they never reach the ground, and we're safe from them. If you expose someone to ultraviolet light, or even worse, X-rays or gamma rays for a very long time, you can cause a lot of damage and burning. So if we want to see other wavelengths of light, such as are emitted by our sun or stars, then we can't actually set up a telescope on the surface of the Earth. Because if we look up, we won't see any gamma rays or X-rays. They'll all be absorbed by the upper atmosphere. If we want to see what a star looks like in the X-ray or the gamma ray spectrum, then we need to build a telescope out in space and then use it. And of course, this is why we have things like the Hubble Space Telescope or the SOHO Solar Observatory that observes our sun in different wavelengths. X-rays and gamma rays sometimes have similar levels of energy, but physicists distinguish between them because they're created in different ways. So how are they created? Well, think back. What was the difference between X-rays and gamma rays? The answer is that X-rays are produced by electrons, but gamma rays are not. Gamma rays are the product of nuclear reactions that occur in the nucleus of radioactive atoms. They tend to have more energy than X-rays. If we get certain type of radioactive material that emits a lot of gamma rays, we say that it is emitting gamma radiation. Alright, so what about X-rays then? It turns out that X-rays are produced by rapidly changing the energy of an electron. So we can do this with a device called an X-ray tube. These are of course a bit cheaper to get than pieces of radioactive material, and they last longer. And because X-rays have lower energy, they are also a little bit safer than gamma rays, although of course still dangerous if you're exposed to them for too long. Well, that's the end of the questions. So we've covered the electromagnetic spectrum in this lesson. That's radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays and gamma rays, in the order of least power to most power.